Hello students. So already in last two classes I have discussed about the current and voltage. So current and voltage is already over. So we'll start after this current and voltage. So we got this one. The synopsis was that when the charge flows through a conductor, then it creates the current. That means current, we said in this way, current is nothing but this is the flow of charge. Flow of charge is the current. If current I should be equal to, suppose q charge is passing for time t, so it is q by t, and electron is the charge carrier. So if there are n number of electrons, so we can write q equal to n into e. So from there we can write this also ne by t. That is the expression of current, and current is nothing but the flow of charge. That means when the charge flows through a conductor, this is a conductor, through there are free electrons inside it. When this free electron will move in the forward direction from A point to B point or from B point to A point, then this flow of charge creates the current. So current is nothing, basically this is nothing but the flow of charge particle. Already we have discussed this one. Second, we discussed the point, and the unit is also over, everything, unit is ampere, everything already we discussed. Now the part is the second part, that the charge particles are moving from one point to other point. The question is that in normal case they will move, or we have to impose some condition. Yes, we have to impose some condition. Now what is this condition? Condition is that you have to set some energy difference at the two end. Until and unless you are setting up the energy difference at the two end, the electron will not simply move from one point to other point. That means at this end you have to put some energy, the electric energy at this point, that is called the voltage, and this voltage at the A end is VA. Same way voltage at the end is VB, and when this VA is greater than VB, then automatically electron will move from the higher energy to lower energy level. That means the condition is that until and unless you are setting up the potential difference, that is the energy difference at the two end of the wire, then the electron will not move. And whenever you set up this energy difference or potential difference at the two end, due to this potential difference, electrons will move from one side to other side. So we got another term that is called the voltage. So voltage is nothing but the electrical energy, amount of electric energy at any point in the conductor. And mathematically, voltage definition we got in static electricity also. That means to bring one charge from infinity to a particular point. Suppose q charge you are bringing it, and the work done is W. So the potential definition is that amount of work done to bring unit charge. So to bring q charge, work done is W. So to bring unit charge, the work done will be W by Q. That also we got. This is the mathematical definition of the voltage, and we can find out the unit also. So that was the voltage and that was the current. This part already we have discussed in last two classes. So those who missed, now you can get some outline idea about the current and voltage. So basically, if I change the total circuit, what is going on in our domestic purpose? In our domestic purpose, actually suppose this is the electric lines passes in the roadside. From there the lines are coming to your house. So when the lines are coming to your house, so here the voltage is 220 volt at the pole end of the roadside, and at home our voltage is equal to 0. So we are setting up the voltage difference. Due to this voltage difference, the carrier, that is the free electron in the wire, they are moving from one direction, higher energy level, to the lower energy level. Then they will supply the energy to all the electronic gadgets at your house. So inside your house, all the electrical gadget will receive the energy, and after receiving the energy less electron will go back through this wire, and it will go back to in this way one full circuit is completing. So this is the reason you just set up the voltage and then the current will go. Now two term may come. Suppose at any instant this voltage becomes 0, that means there is load shedding. Voltage at the end of the road is 0, at home also 0. So as the energies are equal, now no electron will flow. So if no electron flows, then what we can say? Current chule gache. In Bengali we say current chala gaya. So current chala gaya ka matlab hai the voltage at the two end becomes equal. That's why we are not getting any current at all. Another thing may also happen, our electronic gadgets, what we are using in our domestic purpose, they are running fully if they get the difference of potential of 220 volt. That is 220 volt, and our home side should be 0. Then only the electric gadget will run very smoothly. But due to some reason, by hooking or some other reason, this voltage at the evening time, suppose it becomes 120 volt. So automatically what will happen? Now the energy difference between the two ends decreases. So when the energy difference decreases, automatically number of electron flow will decrease. Number of electron flow decrease means we know that flow of charge per unit time is the current. So when the number of electron flow is less, automatically current is less. So when the less current will enter into your house, all the electronic gadget will not give you the full light or full speed like this. That's why light become very dim, or the fan will move very slowly. We call the voltage down. This is called the voltage down. That means voltage difference decreases here. So these are the very in short idea about the current and voltage. Already we have discussed everything elaborately there. So you got some idea about what is current, what is voltage, isn't it? Okay. Now come to the point. What is the relation between this voltage and current? So already we have seen that until and unless you are not setting up the energy difference, this is one where, in this where, this is AN, this is BN. So in between these two end, you have to set up the energy difference, and whenever we set the energy, suppose here potential is VA, here potential is VB. So what is our potential difference or the voltage difference? So our voltage difference is equal to VA minus VB. Suppose it is V, voltage V. And for that, electrons are moving from one point to other point. It creates a current that is equal to I. Now the point just now we have discussed, when the difference of potential was 220 volt, more number of electrons were passing, that means current was more. When the difference becomes 120 volt and 0 volt in last discussion, that means the voltage difference decreases, automatically current flow will also decrease. So what is the relation between voltage and current? They are directly proportional. If you set up the difference of voltage more current will move. If you set up the less amount of energy difference, less current will move. In this way, you can write our voltage and current, these two are directly proportional. In lower class also you got this one. From there, we can write V is equal to some constant R into I. R is the proportionality constant to make it equal. Just to make it equal, we draw one constant term, that is called the R. Now the term is that in between this voltage and current, how they are related? They are directly related. So we got this type of relation. So if someone may ask, who is fast? Voltage is fast or current is fast? Now it is clear to you, until and unless you are setting up the energy difference at the two end, you are not getting the current. So voltage is fast. First set up the voltage, only then the current will move, you will get the current. So that's why we write V proportional to I, never we write I proportional to V. That is, there is a trick also. That why we write V proportional to? We can write the I proportional to, because A proportional to B is nothing but B proportional to A. But here we are not using, in any book you will not get I proportional to V. Why? Because voltage is coming fast. After that you get the current. That's why V proportional to I, or V equal to some constant R into I. Now the point is that this R is a proportionality constant. Also this R have some name, we call this is nothing but the resistance. So in class 10 also we got this term is called the resistance. So resistance is nothing but R is equal to, therefore R equal to, from here we can get R equal to V by I. That means voltage by current is equal to the resistance. This term we got resistance. Now what is resistance? Resistance in physical meaning is that whenever the electron moves through the wire, these are the free electrons. That means if it is a metal rod, metal have their atoms. Atoms outer shell electrons are called the free electrons. So whenever you set up the energy difference, then outer shell free electrons, they are moving. But there are atoms. So when this electron will try to move, automatically atom will give the opposition. So due to this atom, the electron cannot move very smoothly. They are getting the obstruction. This obstruction is the resistance. That means if the atom give more opposition, resistance is more. So it depends upon different factors. So this is about the resistance. And this one, that is V proportional to I, or V equal to R into I, whatever you say, this is actually, you know, this is our Ohm's law. This is our Ohm's law. So Ohm's law says that voltage and current are directly proportional if you don't change the condition. That means if you change the temperature, it may change. If you change the pressure, if you change the or focus the light or something else in certain material, then this relation may vary. Otherwise, if you don't change the physical condition, voltage and current are directly proportional. So this you can draw with a graph like this. Voltage along this side, I along this side. So it is V is equal to R into I. That means Y equal to mx type relation. So Y equal to mx means straight line passing through the origin. It means that you are increasing the voltage, you are getting more current. Increase the voltage, you are getting much more current. In this way, it is a straight line passing through the origin. So the electronic gadgets or the instrument which follow the Ohm's law, we call they are the ohmic circuit, as they follow the Ohm's law. And remember, in last time also you have finished the semiconductor chapter. Semiconductor do not follow the Ohm's law. Remember, they do not follow the Ohm's law. So in that particular semiconductor, you don't get this type of relation. V is not equal proportional to I. So these are the non-ohmic conductor. Semiconductor, all the semiconductor device, they are non-ohmic conductor. And ohmic conductor means they should follow the Ohm's law. And this is about our Ohm's law. Ohm's law you can write in this way. After that, let me discuss about something about the resistance, because resistance part is little bit important here. So what about the resistance? I said that resistance is equal to V proportional to I. From there we got V equal to R into I. And this R into I means this R is nothing but this is the resistance. We call this is the resistance, or we can write R equal to V by I also. In this way you can write what is resistance. Now how the resistance will change? See, resistance depend upon some factor. There are several factors, but for the time being I will discuss only about the two factors now. After that I will discuss the other factors on which the resistance depends. Now first of all, the very common one, the resistance depends upon the wear. How it depends upon the wear? Suppose if the length is this much length, and if you increase the length means it is L dash now. So the length is changing. So how it depends upon the length? See, when the length is L, electrons will cover only this much length. When you increase the length, electron have to move more path. More path means more opposition from the atoms, because opposition by the atoms is nothing but the resistance. So as long as it moves the longer path, automatically the opposition is more. So opposition is more means resistance is more. So resistance depends upon the length, or we can write resistance is proportional to the length. As much as length will increase, more and more electron will cover much length. So as it covers the longer length, it gets more and more opposition. That means resistance is more. Second point about the cross-sectional area. This is cross-sectional area, suppose A. Another one I am drawing this where see your cross-sectional area is very small. It is A dashed. So as the cross-sectional area decreases, it means that is पाइप छोटा हो जाएगा तो क्या होगा, इलेक्ट्रॉन जाने में बहुत प्रॉब्लम हो जाएगा. सो इफ द एरिया इंक्रीजेस, then what will happen? Area increases means resistance will fall, because the electron will get easy passes. If you make it very thin means area decreases. When you make it very thin, area decreases, electron will get more opposition, resistance is more. That means area and resistance, these two are inversely proportional. If you increase the area, they are getting enough space, resistance is low. And when you decrease the area, electron will get more opposition, that means the resistance is more. So we can write that R is proportional to 1 by A. You got in class 10 also. If we combine these two, R proportional to L by A. So from there we can write R should be again equal to, so I have to bring one constant term. Let use the letter rho L by A. So rho is the constant, we brought it from outside, this is the constant, and this constant proportionality, it has the name, this is called resistivity. This is called the resistivity of the material. So we can say in this way, resistance up to this discussion, we can conclude that resistance depends upon mainly three factors. So one is the length, it is directly proportional. One with the cross-sectional area of the wear, it is inversely proportional. And one more thing is that it depends upon the resistivity. Resistivity is the special property of the material. It depends upon the material. You will get one chart in the book. For copper wire, resistivity this much. For iron wire, resistivity is this much. So resistivity varies depending upon the material used in the wire. Good conductor material used in the wire depends upon this resistivity. Okay. So resistivity I can extend little bit more here. That resistivity, from there we can say that our resistivity R equal to rho L by A. So what is rho? Our rho equal to will be rho equal to RA by L. So if A equal to 1, L equal to 1, then see rho equal to A equal to 1, L equal to 1, rho equal to R. So what will be the definition of resistivity? Definition of resistivity is that if I take a wire whose length is unity and area cross section is unity, then the resistance of the wire is equal to rho. That means if it is a wire, length is unit length, suppose the cross sectional area is also unity, then the resistance of this wire is equal to the resistivity of this particular material. If it is copper or iron, whatever be, it depends upon this material. This rho is equal to the resistance of this wire when the length of the wire is unity, cross sectional area is also unity. In unit, maybe in all centimeter or in meter or in millimeter, whatever, in same unit, length and area cross sections are equal, then the resistance is equal to the resistivity of the material. And automatically unit also you can write, unit you can find it out from here. R is the resistance. I just forgot to say, you know it very well. The resistance unit is ohm, OHM, ohm. Then area is the meter square, suppose. If I consider the meter, length is meter, so meter and meter square will cancel. So our unit is equal to ohm meter, or in CGS it is ohm centimeter. So this is the unit of resistivity. Okay. At the same time, I can say one more thing, that is ohm centimeter, ohm meter over. Then let me say introduce another one that is conductivity. Conductivity means how much conducting the material is. That means if the resistance is low, it is more conductive. So the conductivity is sigma. Sometimes we use the letter, that is equal to 1 by rho is equal to the sigma. That means the sigma is equal to just opposite to the reciprocal of the resistivity. In this way, conductivity term also we can include here. Okay. After that, we can say in this way that how can we conclude the Ohm's law, what we got V proportional to I or V equal to R into I, how can we make it into the vectorial form? That is very important one, Ohm's law in the vectorial form. So let me stop this video here. In next video I am coming, how can we conclude this one, how the resistivity is yours, the Ohm's law can be converted into the vectorial form, because I said current is a scalar quantity. Remember, current is not a vector quantity, current is a scalar quantity. So if the current is a scalar quantity, V proportional to I, we cannot normally convert into a vector formula, because there is no vector. I is the scalar quantity. So, but the question comes, write down the vectorial form of the Ohm's law. This is the Ohm's law. We write the vectorial form of this one. Okay. So let me stop here. In next video I am discussing this part. How can I convert into the vectorial form? Okay. Thank you.